Okay, so we're just going to have to put up with this chainsaw sound.
Okay, sure.
Okay, so when you're working with quadrants, the first thing to start off is in the first quadrant. So just it goes in this direction. So this is it kind of goes anti-clockwise, and this starts at 0. So if we were to draw our first little triangle in the first quadrant, you can kind of have if you imagine this is a circle, this is a hypotenuse. So in some syllabuses, this gets called your R. It's the same as your hypotenuse.
Yeah.
Then you drop a perpendicular here. Now the first quadrant makes the most sense because it's kind of what you're used to, which is when you have like an angle over here, theta, and then you have you have a right angle triangle, which is in this first quadrant. And when you first learned trig, you learned that sine theta was equal to opposite over adjacent, right?
Yeah.
Equal to opposite over adjacent. Opposite over adjacent. Now, I've done the opposite in blue because your y, you see your opposite is in blue here. This is like your y-axis here. So
yeah.
if you were to put a coordinate here, over here, this would be your y-coordinate. And your adjacent coordinate would be your x. So in the same way that you could say opposite over hypotenuse, you could say opposite. You could say basically y.
Yeah.
Over your hypotenuse. Now your hypotenuse is always positive.
Yes.
So this hypotenuse here, or your r, so we could say h. Now sometimes it's written as r, but r and h are the same things. R is it's written as r when you're studying A levels and at university.
Okay.
Because it's the radius of this circle, if you were to imagine that. Okay. And then your cos theta would equal your adjacent over your hypotenuse. Okay. Okay, and then your tan theta is your opposite over adjacent, or y over x.
Yeah.
So that's how this triangle that we remember, where our adjacent and our opposite is just now, your opposite is now y and your adjacent is x. And this will help us to figure out what is positive where. So there are people who've gone through to matric and written matric exams and done very well with just learning that it's all here because everything is positive. And so they learn this all stations to Claremont or cast diagram.
Oh yeah, yeah, we also use that.
So they just learn this off by heart and they never really bother understanding, or they missed the lesson where they were shown this, but it's actually okay. You can get away with like just learning this, learning that, okay,
Yeah.
sine is positive. Sine is the only thing that's positive here. But let's just see y quickly, and we can also then, it's just better to understand it then. So again, you can drop your perpendicular down here. Okay, now I'm not going to do all of them. I'm just going to do the coordinates. So, so this coordinate here was, and we had an x. So if we were to do the coordinates over here, we notice that we have our x. Yeah, now notice that in this quadrant, x is negative, right?
Yeah.
X is negative here and plus here. So here we have an x is positive. So here technically our x, we have a negative x, right? Negative.
Yeah.
But our y is still above. It's still, y is still positive here. And so we still have a positive y. So if we go to our different things, we see, okay, where are we using x? X over here. So we have a negative x and a negative x. So that's why cos and tan would be negative over here. And sine would be the only thing positive because sine is a y and an r. We know that the r or the hypotenuse is always positive. And the only thing, and the y is also positive. So the negative goes to whatever contains a negative, which is these two.
Yeah. So in metric, like with trigonometry, is it like what I'm trying to understand is,
yeah.
Do you have to use compound angles and everything? Or...
Yes. Well, not always. Sometimes you use the basic trig. It doesn't always. You don't always
so say
compound.
So say they asked us like a quadrant question, like would we have to use the compound angles? Or don't know.
Yeah, so you do. It just depends on the question. So some questions bring in compound angles and just your basic, like regular trig, like Pythagoras. Like it just depends on the question.
Okay.
But in your reductions, you generally always need to know your compound angles and what quadrant is positive and what's negative.
Could we, so will reductions follow after this then?
Yes.
Oh, okay, thank you.
Yeah.
Okay, because I think that's also the main thing that I'm confused with.
Yeah.
So
so this one's negative, negative. So notice that if you had a negative over a negative for tan, that would be why tan is positive.
Yeah.
And then cos is the y is negative, but so the y is the thing that's negative, but the x is positive. And so it makes sense if the y is negative, then sine and tan with the y's here are the things that are negative. And cos, which has the positive x and the r, is the thing that's positive. Okay, so that's the first thing of why everything is changed. The signs are changed depending on the quadrant. And then you have to know with your reductions what the quadrants are labeled. So notice how this is theta, right? Now, if we were to take this angle here as theta, then look at this angle here. And if this is a straight line, this is 180 minus theta. And so that's why this quadrant is 180 minus theta. And this one is theta.
Yeah.
Because it just deals with that. If we were to extend this, keep on going, and this is now theta over here, we get 180 plus
180.
theta. Yeah. And then what's this last one?
Minus theta?
360 minus theta. Yeah. 360 minus
Okay.
theta. So what we do is imagine that this is to if I was to draw this line here, and then this be theta, then I could extend this all the way around to here. And so this full angle here is 360 minus this theta here.
Okay.
Okay, so as I say, people go to matric and never understand why, but all they do is they learn. So if I was to take this full diagram and just put in the bare essentials of what you need to know, it's this. Cost, theta, 180 minus theta, 180 plus theta, and 360 minus theta. And this is all you need to do your stuff.
Okay.
This is all explanation. So
Yeah.
let's say you got a question like, we'll do a simple one to begin with. They make you simplify something like 180 minus x cos, let's make it sine x. Actually, let's make it cos 180. Make it sine. I'm going to make this 360. Sorry, I want this to work out nicely.
So then, like, are we supposed to recognize the equation and then put it into the formula?
No, so in this one, this one we are doing reduction. So this is not the full compound. This is something where it's going to be slightly different from although it is, we will see that it's going to work out quite neatly, but it won't always. But this is just showing how we use the quadrants. This is supposed to be 180 minus x. Oh man, let's just try and get that. Okay. Okay, so here, this is a type of question where you have to reduce everything to a acute angle. Now, anytime where we have a 360 minus, we can actually just take off the 360 and just write that.
Okay.
And then the sine 90 minus x. So, oh, by the way,
that would change to cos.
Yeah, so we see the cos is positive, so that's why I changed it to cos positive, right? 60 minus x, so this is actually just cos x, right? Because it's 360 minus theta, so our theta is x.
Yeah.
Sine 90 minus x is also cos x. We know this because we have you know how the triangle, do you know about the sine 90 minus x equals cos x and cos 90 minus x equals sine x? You've done that yet?
I remember last year you taught me like some trick, because I remember I was memorizing them, like,
Yes.
and then you taught me a trick or something. What was it again?
Oh, they're using the calculator, maybe.
Yeah, I think so.
Yeah.
So like, how would you know how to do that in a test? Like, just because I know that 90 is to cos. Like,
yes. So what you do is so what we'll do is I'll show you the trick afterwards. But
okay.
One of the things is that if you have a 90-degree angle and this is theta, then this is 90 minus theta. Because if that's theta, these add up to 180. So if that's theta, that has to be 90 minus theta. So the adjacent of your theta is the opposite of your. So if we look at the adjacent of the theta, that's actually the opposite to the 90 minus theta. So like your cos. So do you see, if you're looking in terms of this theta in yellow, right, over here, and that's adjacent to the yellow one, but it's opposite to the pink one, right? So if you're looking in terms of the yellow, it's adjacent. If you're looking in terms of the pink one, it's opposite. And so when we look at sine and cos, do you see you've got opposite adjacent? So if it's sine of opposite theta, and then the sine 180 minus sine 90 minus theta would just be your cos theta. So because you see it's opposite and adjacent. So the opposite and the adjacent switch, depending on if you're looking at sine theta and cos theta, and if you're looking at the pink one or the yellow one. So basically, without understanding anything, cos theta is equal to sine 90 minus theta.
Yeah.
Because if we look at our, so let's say that the theta was yellow. There. That means the 90 minus theta. Well, let's make it blue, like how we've written these down. So if we have this as blue, then this one would be yellow, 90 minus theta, because this adds up to 180, this full triangle. And so we have this rule, sine theta is equal to sine 90 minus theta. And what did I say? I don't know if I said sine or cos. But anyway, sine, and then sine theta is equal to cos 90 minus theta.
Yeah.
And that's because this is a right angled triangle, and theta, the adjacent, the other angle, must be 90 minus theta. And because O and A are basically can be just swapped, depending on the angle that you're looking at.
Yeah.
So in other words,
I just remember like all the odd things, so like 90 and 270 change.
Yes. You guys added again. Sorry. So this cos 90 minus theta, we can write, so 90 minus x, we can write sine x. And then the sine 180 minus x, what we do is we look at what quadrants it's in. It's this quadrant. And so it's positive because S is the thing that's positive. And so we have times.
Okay, I know this is a really stupid question. So wait, what do you mean, like, when we look at what quadrant it is, like, do we say, like, where would 90 minus x be?
Yeah, so I'll show let me highlight the ones where I used quadrants. So these two here, I did not use quadrants. These two was the idea that your you have complementary angles.
Yeah.
Where sine 90 minus x is synonymous, or that's not the right word. But it's the same as cos x. And cos 90 minus x is the same as sine x. So I put these in just to refresh our memory on those. So that you learned last year. Then these two are the things we use a quadrant with. So let's look at the first one. So here we look at the 360 minus x, and we go, right, which of the quadrants? And you see that has a 360 minus, and that then tells us that we can put this just to x in, but this thing tells us what the sign must be. So we look at the C, and we're dealing with causes being positive, and so therefore we know, okay, this must be positive.
Okay.
And then when we look at the other one, let's do that. Let's use this light.
So do you, like, you know how certain sections in maths, like it's only a little bit of grade 11 work. With trig, is it basically you have to remember all of the grade 11 work?
All of it, yes. So trig is it's a skill that requires every single tool that you've been shown. So it's like a toolbox. All of these things are like a toolbox which you take with you in order to fix something.
Okay.
So if you have something missing from a toolbox, there's certain things that you can't do. So
yeah,
we need to have all of these together. So we look at that and we say, 180 minus. So then we go to this quadrant, and we see sine is indeed positive here, and so it can remain as sine x, positive.
Yeah.
And so I think the trick I might have showed you is the idea that you can check all your answers. So this becomes cos squared x, and this becomes sine squared x. And we know that cos squared x plus sine squared x is equal to 1. Now, one of the things you can do, which is the trick I might have showed you, is when you want to check your answer and you have like an equation. So let's say that they said prove. Well, you could actually prove this, but it's the big ones come down. You can check this with your calculator, but what I do is I always make x 30. And the reason
yes, that's what you said.
I always make x 30 because I know that sine 30 is a half.
So then
you can put in your calculator sine 360 minus 30 times sine 90 minus 30 plus cos 90 minus 30 sine 180 plus 30 minus 30. And when you put that in your calculator, you get 1. And then you know, okay, I've done it correctly.
Oh, okay. Let me write that down.
So that also allows us, so the trick, so just a reminder of that trick, it allows us to check certain ideas. Let me just save this as a screenshot, and then yeah, so like they give you stuff like sine. Like say you had to reduce cos minus x, and they wanted it to be simple. All you can do is you just put cos minus 30 in your calculator, right? And you see what it gives you. And it gives you 0.8 something, whatever it is. But you'll notice that the calculator gives it to you as a positive. And so you know that cos minus x is just the same as cos x. And then let's say that they give you sine minus 30, right? Sorry, sine minus x. And you go, okay, what is that? Is that positive? Is sine x? And you go, okay, well, let me just put sine minus 30 into the calculator.
Okay, makes sense.
And you notice when you put sine minus 30, you get negative a half. And you go, okay, that must be minus sine x then.
Okay, yeah.
And so that's when you get the question where they could have said cos minus x over, times sine minus x.
So would you suggest that I revise my grade 11 work?
Yes, definitely. Definitely. So something like this. Okay. So when you kind of look at it and you get to understand, okay, we've already seen, but you can put cos minus x into your calculator and you get minus 30 in your calculator, because your calculator doesn't allow you to input an x, but you can put in a minus 30 and then you see, it's the same as just cos x.
No.
And then sine minus x, you go, okay, that's the same as sine minus sine x. And then here, you just quickly draw your quadrant, cast, and then you have your theta, 180 minus theta, 180 plus theta, and 360 minus theta. Okay, and then you go, right, let me just highlight. It's 180 minus, so it's there, so you go, okay, sign remains positive. And then cos 180 minus x, that's the same quadrant, but this time it's cos, but sine is the only thing that's positive. So we must have a minus cos x. And so we see cancel, 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 but it's minus over minus, which is a plus. So we end up with 1. But what you can do as well is you could simply, we're using our trick of the minus 30, right? You could say cos minus 30 times sine minus 30, sine 180 minus 30. Put this whole thing in your calculator, substituting x with 30, and to see, do I get 1 or do I get minus 1, right? Or do I get something else? If I get a minus 1, you know you made a mistake with one of these, because you should have then an odd number of negatives.
Okay.
Okay, because remember, when you have an odd number of negatives, the full answer is negative. If it's an even number of negatives, it has to be then positive.
So is that basically the reduction formula?
So yeah, well, but you do get the reduction formulas, the ones that get given to you, which is now a separate thing altogether, where you use them to simplify things. So what you're looking for is something like this. Sine 37, cos 53 minus cos 37 sine 53. So if we were to look at that and you go, okay, I'm noticing 37, 37, 53, 53. Okay, this in your head is an alarm bell of you can use those 4 formulas that they gave you, which tell you about, where we said cos A plus B is equal to, and then it was cos A, cos, I don't remember what the cos A, cos B was. You probably got it on your PDF there.
Yeah, I'll just send.
Okay, so let's look at what this one would be. So this, you would be looking for sine A cos B minus cos A sine B. So
Yeah.
it may not be in this specific order, but you should see something like that.
Yeah, no, it is that order.
Okay, and so what is sine A cos B minus cos A sine B?
So would we say sine bracket 37 plus 53?
Yes. Okay. Specifically, why did I choose 37 and 53? Because they add up to 90, which is a special angle. So we know that sine 90 is again 1.
Oh, so with most of the like quadrant work with the compound angles, do they want you to land up with a special angle? Usually.
Yeah, so they do, but they don't always. I mean, I could have had this as 27 and then it would have just been sine 80. But that means that you just have to leave it as sine 80.
Okay, but then if you got say sine 90, do you have to change it to the special angle?
Yeah, you change it to 1, yeah.
Okay.
Now, again, you could put this in your calculator as well, sine 37 cos 53. And you could just stick it in your calculator. And you would possibly get 1, or you should get 1. And then you know that you did it right. So the idea is always to be able to use your calculator as a tool to check, but to understand the trick so that you can get these method marks.
Okay. So it's like, it's all the grade 11 work, but except like with compound angles, you can't exactly like, it's not hard. You don't have to understand it. You just have to use the formulas, right?
Yes. Yes.
Okay. So,
Okay, should I stop this? Should I stop this recording and you can
okay.
carry on?